Good day. In this video, we are going to record the calculations involving redox reactions. Right, in the redox reactions, as you may all remember, is that redox reactions are chemical reactions that take place in which the two processes of reduction and oxidation take place at the same time. In the process of reduction, there is the change in the oxidation number of a species from a high value to a lower value through the gain of electrons. So this happens with the reduction or a decrease in oxidation number of a species. From a high value to a lower value. So in the process of the reduction, this whole process occurs through the gain of electrons. So the species that is being reduced gains electrons. The older definitions that are commonly used at the beginning, or that were commonly used in some texts and in some instances, is that the process of reduction is the removal of oxygen. Right? And then another definition that is sometimes used or related to the process of reduction is that it is the gain or addition of hydrogen. So now, on the other hand, when you talk about the process of oxidation, right? So oxidation your broader definition occurs through an increase in the oxidation number of a species, right? So now this increase in the oxidation number occurs when a species loses electrons. Remember, electrons are negatively charged species, so they if you add electrons, the oxidation number would become less, whereas if you remove electrons, the oxidation number will become more. Hence that definition that there will be an increase in the oxidation number of a species. Now, the process, as we said, happens through the loss of electrons. In some definitions that you've seen that are there, is that the process of oxidation happens through the addition of oxygen. That is where actually this term came from, the addition of oxygen being a process of oxidation. Addition of oxygen, or the removal of hydrogen. Take note, when you define oxidation or reduction, they are opposite of each other. So once you've learned the definition of one, the other one becomes the opposite of that which you are defining. If you are given an example to calculate, and the question is as follows: oxidation numbers make it easier to determine whether an element or a substance is oxidized or reduced during a chemical change. Define the term oxidation with reference to oxidation numbers. Well, as we said earlier, that oxidation is what? Is an increase in what? Oxidation number of a species. Calculate the oxidation number of chromium in dichromate. Well, I will just copy that down here. So you've got your Cr2O7 minus. What you do know is that the oxidation number of oxygen is going to be -2 in the dichromate ion. So what you do is you count the number of chromium ions whose oxidation number you want to work out, and you count there are 2 of them, and each one of them is carrying an X oxidation number whose number you do not know, plus the 7 times the -2 for the oxide, and the 2, and that will give you the net charge, which is equal to -2. We then go on to solve for x in this equation. So you'll have 2x minus 14 is equal to -2. Solve for x by transposing the -14 to the other side of the equal sign, and it's going to be equal to -2 plus 14, and then this is going to give you 2x is equal to plus 12. Divide both sides by 2, and you will have your x being equal to plus 6. That is the oxidation number of chromium in dichromate. So it's equal to plus 6. Calculate the oxidation number of oxygen in H2O2. So when we now calculate the oxidation number of oxygen in H2O2, what we're going to do is a similar process, but in this case the H2O2 does not have a net charge. Its net charge is equal to 0. So you will have 2x plus your 2 so it's 2 times 1 for the hydrogen plus 2 times x for the oxygen in the peroxide, and the net charge is equal to 0. So it's 2 plus 2x is equal to 0. So you transpose the 2 to the other side, so you'll be left with 2x is equal to -2, and then thereafter when you simplify that, you are going to get the charge for x being equal to -1. So what we have learnt in this video is the definition of oxidation numbers, and also the definition of reduction. We have also shown you how to calculate the oxidation number of a species in a given circumstance or substance, and then you've also been able to show the charges that each one of them carries. We hope you enjoyed this and that you can always go back. It can be useful for your further revision.